As we go on now to topic 2 of chapter 2, here we're going to start doing equations. And as I probably did in class, I created something like this perhaps, in which as we think of equations, this is our equal sign here. And we're saying what's on the scale on this side is equal to what's on the scale on this side, and the scales balance. And if we add something to this side, and we add something to this side, and it's the same, they will still balance, but it's not the original amount. So what we're going to go through here, all of these, is eventually we want to do various things to the equation so that on one side we have our unknown, and then on the other side we have a number. And the steps that we go through are called solving an equation. And that's what we do. So we're starting off with here just the idea, is 14 a solution for this? So we put a 14 in there, and this then becomes a 10. So 9 times 10 is 90. And we put a 14 in there, and this becomes a 9. And 9 times 9 is 90. So the answer is yes, 14 is a solution for that. So now, using all of the items we were going over when we had the lesson on this in an earlier video, what do we do to solve this? And again, I'm not going to write a lot out here, but as needed I would. So here we're just going to subtract 8 from both sides. That's part of our little scale here. And we end up then 8x, I should say, equals 4. So a very simple solution. So 4 plus 8 equals 12. But we use the additive inverse to get rid of the 8 on this side. Now here we're going to add 14 to both sides. And we get y equals 26. And then here we're going to, I'll do this one out because this is a negative x. I'm going to add or subtract this from both sides, and we get 0.4 when we subtract this from both sides. And now, in order to get a positive x, we have to divide by a negative 1 both sides. So this then becomes x equals a negative 0.4. All right, now they're getting a little more complicated. And let's get some room. So we have here now 5/8 plus k equals 1/2. So we're going to subtract 5/8 from both sides. I didn't write it on this side. In fact, a method I'm going to introduce is that we take a term from one side and move it to the other. We just change its sign, which is like subtracting from both sides. So this then becomes k equals, now we have to have common denominators here, and this will become 4/8 minus 5/8 would leave us with a negative 1/8. Now, number 6 I wrote up here, and as we look at it, one of the things we always like to do is to try to keep the variable positive. So if I subtract 13x from this side, this will become a 0, and 13x from 14x, I'm left with an x. So x equals a negative 11, and that's the answer. Now for number 7, I wrote that out here too. And in Math Zone, I was watching a number of students this summer, and they have developed this technique on their own, that as they do it, they write the equation out, and they will physically, it's like subtract a negative 2x from this side. That'll make that a 0. And then to keep it balanced, the negative 2x from this side, and you get the x. And then in the next stage, they're going to subtract the negative 1 from both sides, and here they get x equals negative 9, and that is correct. So the technique that you are developing, these series of steps, here there was only one, but here there's like 3, this series of steps, and notice I try to keep the equal signs lined up, are called solving an equation. Now in our video lab, you recall I wrote on the side a number of things that you're going to do. Get rid of fractions, get rid of grouping symbols, combine like terms, transpose to get all the x's on one side, numbers on the other, and then later we'll be dividing by the numerical coefficient of the x. And again, there is a sequence that you follow in solving equations. Now in doing example 8, and 9, and 10, and 11, it's just using the principles and would use up some of our time. I could do them, but there's not a new skill there, and these are the answers. But when we jump to number 12 now, we see we have fractions. And again, it's never too soon to start what would be the strategy for getting rid of fractions. And the answer is multiply every term by the least common denominator, which happens to be 5. So that's what the blue indicates. So 5 times 9 is 45y. But now the 5's cancel out, and I'm just left with a 1, negative 1. Here 5 times 8 is 40y. Here the 5's cancel out, and I'm just left with a 2. And now I don't have to worry about fractions anymore. Now, is it the same equation? No, but it's an equivalent equation. It still balances. So here I'm going to add a 1 to both sides. That gives me a 3. And then I'm going to subtract 40 from here, 40 from there. That gives me a 5y equals this. And now here's the other new technique. How do we get rid of the 5? That's with the y. And the answer is we are going to divide by the numerical coefficient, which is a 5. So here, this cancels out. I'm left with a 1 that I don't write. Y equals 3/5. Now, in example 15, you don't need to get rid of fractions here because just distributing that, it's going to go evenly. Now, you could have multiplied everything by 2, but in this case, you'd make a different direction, so to speak. So negative 1/2 of 2x gives you a negative x. A negative times a negative gives you a positive, and 1/2 of 10 is 5. And I'm just going to move this over, or in this case, add 2x. Add 2x, that gives me an x. subtract 5 from both sides. That gives me a -1, and there's my answer. Now in doing example 17, and by the way, I did put answers up for the others that we're not doing. We're already over 10 minutes here. But to get rid of the fractions here for number 17, we have a 4 and a 5. So my common denominator is 20. I'm going to multiply every term by 20. So here it becomes this, but here the 4 goes once, and this is 5. Here this is 120y, once and 4. So this gives me an 8. So much easier to deal with. Now I'm going to add 5 to both sides, gives you a 13. Subtract 120 from both sides, that gives you a 20y. Divide both sides by 20, and that gives you our answer. All right, in these next 3 examples, they're starting to prepare you for word problems that come a little later, but some very good techniques here. For instance, if we have angles that average or that total 150 degrees, then this little box can stand for 150 degrees. X is part of them. What's the other part? Well, it would be the total minus the x degrees. So here are our 2 answers. Now here we have a board that's 15 feet long that's cut into 2 pieces. If one piece is x, what would be the other piece? Well, 15 minus x. Notice we're using the same technique. Here's the total, a way to divide the total up into 2 parts. Now, here we have a town that we don't know the distance, but that distance is m. Well, the other town is 15 miles more than that. So this would be m plus 15. So Gastonia, its distance is m. Lincolnton is m plus 15. And that's how you would show these. So again, more practice later. This one ran, I see, a little over 13 minutes. And we didn't do every single example. But again, if you need help on something, be sure to ask your instructors and your tutors. That's what we're there for.